Here we go, last page of our marathon notes here. Some quadratic trinomial expressions do not have a simple x as the variable, or just a straight variable, but rather have some sort of function. So it's best to use some sort of substitution. So we're going to use substitution to make factoring easy. It's going to simplify it. Consider m minus 2 squared minus 9m minus 2 plus 14. This expression uses m minus 2 rather than the traditional variable. So we use an m minus 2 rather than an x. We can substitute x equals m minus 2 into our equation to make it way easier to factor. When we do that, m minus 2 would become x, that's x squared minus 9x plus 14. That is far, far, far easier to factor. Just remember, replace back the function. So important to put it back in there. This first example I have here, m minus 2 squared, is basically the one from above. What I did is I let x equal m minus 2. We ended up with x squared minus 9x plus 14. This factors into x. What are we multiplying? 7 and 2, x minus 7, x minus 2. Which is not bad, it's a good factor, but we're not talking about x's here, we're talking about m's. So let's replace x with m minus 2. And let's replace x with m minus 2. And we get a factor of m minus 9 and m minus 4 as a factored quadratic expression. Why don't you try a similar technique on question B there. Use a substitution of some sort. Let's let m equal some number, some expression, and give that a try. In this case, I'm going to let m equal 2x plus 3. So we have m squared minus 2 times m minus 8. Certainly factors into m times m, 8. Could be 1 and 8, 2 and 4 looks like the right answer. 2 and 4, negative 4, positive 2. And if we replace m, again, we're not dealing with m's in this question. We're dealing with 2x plus 3 and 2x plus 3. We end up with the expression 2x plus 5 and 2x minus 1 as our factors. Lastly, you may recall factoring a difference of squares. Difference of squares, when we have a perfect squared minus a perfect square, will factor into x plus y in this case and x minus y, if we're talking about the difference of squares of x squared minus y squared. Now, in this case, it's usually easier to write the terms in the difference of squares as perfect squares. So certainly 2a plus 1 is already written as a perfect square. What I want to do is maybe take the 9b squared and rewrite it as 3 times b all squared. There we go. We see the 3 being squared to give us 9, and we have the b squared. So this would be like our x. This would be like our y in the above equation. So we should have x plus y, x minus y. Look for any simplifying in this case. 2a plus 1 plus 3b doesn't really simplify at all, nor would the second term there, so we can just ease it off right there. In the second example, you should always think about factoring out a greatest common factor first. And in this case, we can pull out a 3, leaving us with a 16, 3x minus 2 squared, and a 9, y plus 1 squared. Now I'm going to start using a lot of brackets here, but really it's just so that we can see the coefficient there, the 16 and the 9 as perfect squares, in this case 4 and 3. So it's going to be 3y plus 1. Let's move that outside. And that leading 3 is still there. So our perfect squares in this case, that would be our x, and the 3 bracket y plus 1 is our y value. Or if we could, sorry, maybe not use x and y, let's use a and b in this case. So 3 is certainly just a coefficient that's sitting out front. We're not going to touch that at all. We have a plus b. And we have a minus b. And simplifying in this case, we have 12x minus 8, 3y plus 3. We have 12x minus 8 minus 3y, and minus positive would be negative 3. And simplifying, 12x plus 3y minus 5. 12x minus 3y minus 11. A bit of a marathon question, but the techniques are pretty sound. That ends notes on solving quadratic equations, the factoring of polynomial expressions.